Alright, in this video I'm going to talk about how to solve multi-step equations, kind of some of the vocab, how to actually solve them, and some things related. So let's get right into that. The first thing in the notes asks a question: what is a solution? And before I continue, disregard this Smart Notebook limited mode. There's issues with Smart Notebook. Anyway, what is a solution? So in your own words, what would you say a solution is? Here is, and the definitions are worded differently depending on where you look. Here is the definition I have found: a value we can put in place of a variable that makes the equation true. So let's think of something simple. 2 times what will give us 4. That what is, let's say, the variable we don't know, and if we knew the variable or knew the value of the variable, 2 times what will give us 4. If we knew it to be 2, then that would be the solution for this problem. Now we're going to determine if these are solutions or not. So the way to do this is to put 5 in for x, or you're evaluating. So this shouldn't be new, as we've done this in the last module. I'm going to pull up my calculator. Alright, and then the first thing I did was reset it, and then we're going to go ahead and find this problem, or do this problem. Is x equals -5 a solution for this equation? 13x minus 7 equals 58. So I'm going to go ahead and I'm going to put 5 in for x, and you can do that by either using your stow button, using your parentheses, really either of those. I'm just going to use my parentheses. 13 times 5, was that minus 7? Yeah. Minus 7 is supposed to equal 58. So I'm going to go ahead and test this using second test and my equal sign. And remember, your calculator talks to you. So if it's a 1, this is a solution, it's correct. But if it's a 0, this is not a solution, it's not correct. We got a 1 in this case, and that is correct. Another way you could have done this without the equals is just done the left side. So 13 times 5 minus 7. And you can see that this is 58 and it's supposed to equal 58, which is true. So when questions ask you to determine if something is a solution or not, really you're just evaluating. See if you put this in for x or substitute, do you get the answer they want? If yes, it's a solution. If no, it's not a solution. So I'm going to go ahead and say yes for this one. Now let's think about number 2. It's almost the exact same problem. The only thing that has changed is this is now -5. Do you think this is going to be a solution? Take a second, try it on your own, and pause the video if needed. And I'm going to go ahead and go back up and grab this equation, and I'm going to change this to -5. So I'm going to hit insert because I don't want spacing to mess up. And I'm going to put in my negative. Now this gave me a 0. It's saying something about this is wrong. We know that the negative made it wrong, but let's see what actually happens when I do 13 times -5 minus 7. We get -72, which is definitely not 58. So this is not a solution to this problem. Try number 3 on your own. Take a second, pause the video. And I'm going to go ahead and do it in the calculator. Oops. And I'm going to do it backwards. I don't think that matters. -1, or I'm sorry, not backwards per se. It's written backwards where the what it equals, or the final solution, is on the left instead of the right, which is fine. It doesn't matter. Now I've forgotten the problem. 3 plus 4x with x equal negative 2. 3 plus 4 times negative 2. Here this is saying this is not a solution. So let me put this right side in. First, make sure I've typed it in correctly. Yes. Put this right side in and see what it actually does equal. So 3 plus 4 times negative 2 is negative 5, which is not equal to negative 1. So this cannot be a solution. Try this last one on your own, and I'll go ahead and do it in the calculator. Y over 2 plus 5 equals negative 12 with y equal to negative 34. So in this case, I need my fraction bar, alpha y equals negative 34 over 2, yes, plus 5 equals negative 12. And this one told me that this is correct. So if I were to do negative 34 over 2, well, I know that's negative 17. Negative 17 plus 5 is negative 12. And I can do that part again just so you see it. So negative 34 over 2 plus 5 is negative 12, which is what we wanted. So negative 34 is a solution. Oops. So whenever the question asks to determine if the following is a solution or determine which of the following are solutions, really all you have to do is evaluate. On this next page, these are justifications. So think back to like your algebraic properties. This is kind of along those lines, explaining or justifying what was done in each step. But then it takes it a little bit further. It talks about these properties of equality. And what those mean is that whatever you do to one side, you have to do to the other. So if you add something on one side, you have to add that same something to the other side of the equal sign. Same with subtraction, multiplication, division. Now, distributive property, as I've stated here, that's not necessarily done to both sides. Like in this first example, I have a number outside of parentheses, and I could distribute this one side. I don't need to do that to both sides. So that's why it doesn't say property of equality, because I'm not necessarily doing it to both sides. But this does still keep the equation balanced. This says they ensure that the equations stay balanced in order to solve, so that does help in this process. I'm going to do one with you, and then I'm going to let you try 2 and 3 on your own. The answers will be posted on the answer key. So in this first one, this given, that's a always. That's saying this is the equation, nothing's happened yet. In the second sentence, or in the second part, we're looking for what happened between step 1 and step 2. You may have noticed that they took the 2 and multiplied it to the x in the negative 9, or distributed. So I can say, oops, this is way too big. I can say that they use the distributive property here. Now let's look at the third step. What happened, or what changed from here to here? If you're looking at it, you should see that the negative 18 is gone. And when we are doing these properties of equality, we're doing the inverse operations, which means if this was a negative, the opposite of a negative or opposite of subtraction is addition. So I would have to add this 18 to the other side. And I meant to say this earlier, but the goal here is to get the variable completely by itself on one side of the equation and to have just a constant left on the other side. So here, we can't really do anything to get the variable by itself until we distribute. And then once we've distributed, well, we have this constant, we have this constant, we could combine them. But I do want to mention this because last module we talked about combining like terms. And when we did that, they happen to be on the same side of the equation. In this case, if we are combining like terms, we are using inverse operations or our properties of equality to move things to the other side. So we can't just take whatever the, symbol or sign of the constant or the variable term, we have to do the opposite. So here, again, we'd have to add 18 to both sides. So if we add 18 here, that additive inverse would happen. This would become 0. When we add 18 here, that negative would become a positive. So in this case, this would be addition property of equality. I'm going to have to move this over. And I'm going to copy part of this. Alright, and then in this last step, you should be able to tell what happened from here to here. If you said they divided on both sides, you are correct. So they use the division property of equality to get from step 3 to step 4. So really this is all this is. Looking at each step and seeing what was done next, and did they do it to both sides. So again, I'm not going to fill in 2 and 3. I want you to try and do those, but the answer key is up there. All right. I kind of jumped into this already, but we'll go through this again. So when we are solving equations, we need the inverse operations. We need to use the inverse operations. So if we see addition, let me do this really fast. If we see addition, the opposite of addition is subtraction. Thought that changed. It's going to be a little smaller, but that's okay. If we see multiplication, the opposite of multiplication is always division. I know that says subtraction. I'm just copying and pasting so I can use that same color. Oops. Okay, we're not. And because we just did this, the opposite of division is then multiplication. And because we just did subtraction, we know the opposite of subtraction is addition. Now let's look at these. You may see what the inverses are already, but let's talk about them. So when you square something, you're taking whatever the number is and raising it to the second power, or you're taking whatever the base is, that number, and you're multiplying it by itself once. When you square root something, you're looking at what times itself would give you the number inside of the square root, and then the number you use to get that would be your answer for the square root. So square and square root are inverses. I'm going to show this to you on a calculator just so you see kind of what I was talking about. So let's take 5 for an example. 5 squared, or 5 raised to the second power, is 25. If I take the square root of 25, I'm looking for what number multiplied by itself gave me 25, and that would be 5. So they kind of undo each other. So instead of typing these two out, I'm just going to draw arrows. So then you can assume that these two are also inverses, the cube and the cube root. And it works the same way as the square and the square root, and I'm going to show you that. Oops. So if I say 2 to the third power is 8, and then I want the cube root of 8, I'm going to go into math and do number 4. I'm looking for what number multiplied by itself 3 times now will give me 8. And that's 2. They undid each other. So now that we know that, we can talk about how do we actually solve. So these are not absolute steps, and I'm going to talk about that here in a second, but let me read these and then I'll talk about how these aren't absolute. So for now, our steps are distribute, if there's something to distribute, combine your like terms, move the constant by adding or subtracting, get the variable alone by multiplying or dividing. Now, I want to talk about a couple different things because sometimes we don't have to distribute, so step 1 is gone for some of the problems or equations. Combining like terms is only if they're on the same side, so that's really important. Let me write that down. Only if on the same side. So one thing I really like to say in these situations to kind of help you remember, same side, same operation. So that kind of helps you with your combining like terms. This number 3 says move the constant by adding or subtracting, but that's not the only thing you can do. Sometimes you can move the let me scratch that, restart. You can always move the variable. It may make more steps than you actually want, but you can move the variable instead of the constant. So that's not a definite. But your goal is to get the variable alone on one side and then the constant alone on the other. We're going to do some of these together, and then the others will be posted on the answer key. So let's start off with this simple one. I'm sorry, a simpler one. In this case, we're following the steps. We don't have anything to distribute. There are no parentheses. On this side, we can't combine either of these terms. On this side, there's only one term, so we can't combine like terms. So number 2 is even not a necessary step sometimes. Move the constant by adding or subtracting. So if you think back to what a constant is, it's the number without a variable. So this -2. If I were to move this to the other side, I need to use inverse operations. Here we have a -2, or this could be the same thing as -2. So if this is negative or it's subtracting, to undo this I have to do what? Add, right. What I do to one side, I have to do to the other. I can't just pick and choose, oh, I want to do this here. No, it has to be done to both. So then I'm left with 3x equals, I'm sorry, I'm writing on my computer, so it's a little sloppy, 6. And I just went ahead and I took positive 4 plus 2, and I got 6. So that was my addition property of equality that I just did. Now, I still need to get the variable alone or by itself. How would we do that? If you said dividing by 3 on both sides, that was correct. What I do to one side, I have to do to the other. So if I divide 3 here, I have to do that here. When I divide these both by 3, or this 3x by 3, these 3's cancel, for lack of a better word right now. But it's really saying 3 divided by 3, which is 1. So I'm going to write that down first. But because we don't necessarily write the 1 in front of x, we don't have to put 1x. We can just put x equals 2, and it would be the exact same thing. I'm going to box this answer in with a bright color so you can see it. There we go. Now, we got a solution. You should always be double checking to see, does this solution work, and to put this back in. So you can do that by hand, by calculator, doesn't matter. I'm going to talk it through and then put it in the calculator. So if I put 2 in for x, 3 times 2 is 6. 6 minus 2 is 4. 4 equals 4, so this is a solution. And I'm going to do it in the calculator. So 3 times 2 minus 2 is equal to 4. Gave me a 1. This is correct. Alright, let's talk about this number 3 here. Because it's almost the same, but it's a little different. Going back to the notes, we don't have anything to distribute. We don't have any like terms on this side or on this side to combine. So we can start by moving the constant by adding or subtracting. Now if you wanted to move this first, that's fine. You'll just have to still move the 115 back over. So you're still moving the constant if you move the variable. Right? As we saw in this first example, we're subtracting, or it's negative, and the opposite of that is addition. So we would need to add 25 to both sides. That's 2 over 3 p equals 140. Yes. All right. Now we have this fraction next to the p. What's kind of different about this compared to like number 2, if you had already maybe tried that, or when you look at that later, is really just placement. Because I can go back to number 2 and I can say this is really 1m over 4, or it's the same thing as 1/4 m. These two things are the exact same. It's just where they're putting the variable. How you solve it is the same in both cases. In this example, so I'm going to give you guys a hint. Since 4 is being divided by m, I said that backwards. Since m is being divided by 4, the inverse operation for that is multiplication. So you could do the same thing here. Let's say p was up in the numerator with 2, and it's being divided by 3. So you could multiply both sides by 3. So I'm going to do this both ways. Or this way and the other way I'm going to show you. So let's erase this for a second and rewrite this. Let's say this is now 2p over 3, which is the same thing as 2/3 p, which is placement. And I'm going to say that I'm going to get rid of this 3 now by multiplying it to both sides. I'm going to multiply this entire fraction by 3 and this number by 3. When I multiply this number by 3, I get sorry, I blinked for a second, 420. When you multiply this 2 over 3 times 3, what happens? You should recognize that as your multiplicative inverse. Because here, if the 2 wasn't there, that would really be 1/3. And this is really 3 over 1. So this 3 and this 3 cancel each other out to become 1. So all that's left is just 2p. This step looks very similar to what we did up here. So from here we would need to divide both sides by 2. To get 210. So I'm going to put that up here. P equals 210. Draw my little box. It's crooked because I wrote that crooked. There we go. Alright, now I said that there was another way you could do this. And this way, I won't say it's easier, but it's less steps. Because you're kind of doing both of these steps in one. So let me rewrite this. Okay. This works anytime you have fractions. If you have some fraction with your variable, and let me say that p was back on the outside here. So let me fix that. And again, it doesn't matter if p is on the outside or how I just had it. So if it's like it was in the problem or how I changed it, it doesn't matter. So I could have left it. But when you have a fraction with a variable, you can do both of these steps in one by multiplying by the reciprocal. Now, let me explain what that means. The reciprocal of any number is taking whatever it is and flipping it. So if this is 2 over 3, if I flip it, it would be 3 over 2. And the reason we multiply by this reciprocal, let me write it down first, is because this should look familiar. This is your multiplicative inverse. You're multiplying by, let's say this is a over b, and now I have b over a, and that is going to multiply together to become 1. And here, if I'm doing the same thing, except I wrote the wrong number, this should be 3 over 2. Here, I'm doing the same thing I did here. I'm multiplying by 3, and I'm dividing it by 2, just at the same time. So here, this 3 over 2 times 2 over 3 is going to give me just 1p, or just p. And then when you do this, you kind of have an option. You can do what you did before, 140 times 3 divided by 2. Or you can do it, if you're doing it in the calculator, just 140 times 3 over 2. Now, this next thing I'm about to say may not be something you see often, but what you could do is do it a little backwards. 140 divided by 2, so that would be 70. And then take 70 times 3, and 70 times 3 would still give you 210. So whether you multiply 140 times 3, then divide everything by 2, multiply 140 times the entire fraction, or even take 140, divide it by 2 first, and then multiply it by 3, you will still end up with this answer of 210. All right, let's talk about number 5. I'm not going to do number 5 completely. I just want to show you that this is different and that there are 2 different ways to do this, which is why I said these rules or these steps aren't absolute, like you don't have to follow them to a T. Now, in this first example, I am going to show you how the rules or the steps would have you do it. And that first step is to distribute. So if you did that, you'd have 15 equals, we are multiplying here, so negative 6q. Now, when you multiply a negative times a negative, what does that get you? Should be a positive, always. 2 negatives always makes a positive. Just keep that in mind. Now, this equation looks very similar to the first one we did, except our constant is positive now, so we would have to do the opposite of that, or the inverse of that, which is subtraction. Okay. I want to show you one additional way you might be able to solve this, or you could solve this. I'm going to rewrite this. (15 equals negative 3, 2q minus 1). Right? And when I do this, I want you to pay very close attention because we've been taught to do it in such a certain order that when you see it done this way, you think it's wrong. But that is not the case. If I looked at this problem and I said, I could divide both sides by negative 3 and use my division property of equality first before I distribute, that would be perfectly fine to do. There's no law against doing that. I will say you can't always do this. The reason I can do this right now is because negative 3 can be is divisible by negative 3, and I can divide 15 by negative 3, and it would give me some whole number. If you go to do this and you end up with decimals or fractions, you might confuse yourself more than you want to. And if that's the case, if you do end up with fractions or decimals, which is not always wrong, but if you do end up with fractions or decimals, maybe go back to using the distribution method first. Right? So if I do this, these negative 3's cancel, again, because of that multiplicative inverse. I'm multiplying by 1/3 or dividing by negative 3. So this would be negative 5 equals, these would cancel each other out, leaving just 1. But I don't need that 1 in front of these parentheses anymore because 1 times anything will just be whatever I multiplied. So I can just put what's inside the parentheses. And right now this has become a different equation than up here, but it will be solved very similarly. And that's okay. I do want to point out that sometimes you will get fractions or decimals as your final answer, and I don't want that to deter you from thinking you did this right, because there are often decimals and fractions for answers. Alright, we're going to do a couple more, a few more. We're going to do 6, 9, and 10. Let me see if I can copy this over. Yes, I can. Okay, so this is number 6. And when we're doing number 6, we have to go back and think about fractions in general. So what I'm going to do is I'm going to rewrite this without the variables. I'm going to pretend that x is just 1 for right now. That's not the correct answer. I'm just going to do that for right now. I'm going to say 2 over 3 plus, and I'm going to pretend that x is a 1 over 2. I'm not going to put equals 7 right now. I just want to go back to this concept. When we are adding fractions, there is one thing that we need to do before we can add these fractions. What is that? If you were thinking about it and said something similar to you have to get common denominators, that is correct. And there is 2 ways to go about solving this, which I will show the other way here in a bit. So let's say we start off with that first way of getting common denominators. First, we have to think of a common denominator that both of these numbers have. Think about the multiples of these numbers, so 2, 4, 6, 3, 6, so I can change both of these to a 6. If I change this to a 6, that means I'm multiplying by 3. Remember our property of equality rules, what you do to one side you have to do to the other? Kind of the same thing for fractions, except what you do to the denominator or the numerator you have to do to the other. So these both have to be multiplied by 3. Here I have to multiply this by 2. That means this also needs to be multiplied by 2. This changes this to 4 over 6, changes the fractions, sorry, to 3 over 6. When you have the same denominator, you can combine these two numerators and put them over the same denominator. So taking what we just did, we're going to apply that to this. 6 is the common denominator, so that part has not changed. I'm still multiplying this and this by 3, and this by 2. So I'll end up with 4x over 6 plus 3x over 6, which is very similar to what we had here. Okay, where was I? Sorry, I had to answer a phone call. Here, now that these both have the same denominator, I can combine these just like I did here. 4x plus 3x all over 6. And I just realized I've been forgetting my 7. So let me go back and bring my 7 down. I wasn't doing that for this one because I was just showing an example. Now, we can, so these aren't really in the rules because we didn't distribute anything, but we can combine these like terms because they are on the same side. They both have an x, so I can add them together to become 7x. And now this becomes a simpler equation. Now I'm looking for, how do I get x by itself here? Well, I have to get x by itself and I have to get rid of this 6. 7x is being divided by 6. So in order to get rid of that 6, I need to multiply this entire fraction by 6. And multiply the 6 on this side. When we do that, these 6's cancel or become 1. And then I have 42. 42? Yes, on this side. From there, I can just divide. So I can say that x equals 6. Now I'm going to check this in my calculator just to make sure. So 2x over 3, let me do this step by step. Use my alpha, y equals 2x, where x is 6, over 3, plus x over 2, so 6 over 2, equals 7. And it said this was correct. Right? Now I said that there were 2 ways to do this, so I'm going to go ahead and show you the second way. First, let me copy this again, or paste it again. Okay. Right? Now, you may be thinking, I'm not really good at fractions. Is there a simpler way? I wouldn't say it's simpler. You're really doing the same thing you were doing, but kind of doing it all at once. So here, let's say fractions is not your forte, for lack of a better word. And you want to completely get rid of the fractions altogether, which you can do. There's no law saying that you can't, as long as you do keep like your properties of equality rules intact and things like that. So I know that the common denominator for this is 6 from the example we just did, or what we just did. So instead of making the denominator here and the denominator here 6, what I could do is multiply this entire side by 6, and then multiply this by 6. Now you're probably like, why did I do that? Stay with me for a second and watch, and it should help you to see why I did that. Right? Now, when I do this, I'm pretending that this 6 is outside of these parentheses so that I can distribute. Remember when we were talking about the example, let me go back to it, for 140, where did it go? Where I said you can multiply, then divide, you can divide, then multiply, or you can multiply all together. This is kind of the same thing. Here, you could multiply, then divide, you could divide, then multiply, or you could multiply this 6 times the fraction 2/3. Whichever method you choose, it will always work, as long as you're doing the math correctly. I'm going to take it step by step, so I'm going to multiply and then divide. But if you choose to do something else, it should still give you the same answer. So when I'm multiplying this, because this is in fraction, I am not multiplying the 6 to each numerator and denominator, just the numerators. The reason this is because all whole numbers are really over 1. So if I pretend that this fraction, I'm doing air quotes, I don't know why I did that, like you could see me. I'm pretending that this is a fraction, and I'm multiplying this fraction to this fraction. So 6 times this numerator, 2x, 1 times 3, just for the first fraction. So I can say this changes to 12x over 3. And then 6 times x, which would just be 6x, or if you're confused on how I got that, remember that there's a 1 in front of x. So if you multiply 1x times 6, you would get 6. And then 1 times 2 is 2. And then 7 times 6 is 42. Now, right now we still have fractions, and I know you're probably thinking, I thought this method was supposed to get rid of the fractions. It will, we just haven't gotten that far yet. We're about to. So remember I said multiply and then divide. So if we multiply, or like we just did, now we can divide. I can say 12 divided by 3, well that's 4. 6 divided by 2, well that's 3. Oops, that was supposed to be an x. And now this doesn't have fractions anymore. Now I can combine my like terms, because these both have x's, and divide. And you're going to get that same answer we got before. X equals 6. So that's just a different way of looking at that, problems like that. So when you see, sorry, I'm losing my words. When you see equations, I kept trying to say examples. I'm like, that's not the word I was looking for. Anyway, I'm rambling. When you see equations like this, you're going back to that, I need the denominators to be the same concept, so that you are multiplying your numerators and denominator, or you're multiplying both sides to get rid of the fraction completely. Combining like terms if you have them, and solving. So I hope I didn't go too fast and that made sense. You can always re-watch the video if need be. Right. I said 6, 9, and 10. Alright, 4 and 9. The very first thing we're going to do is distribute. When we distribute, because this has a negative in front, we have to take that negative into account. So we're going to have 4m minus 15m minus, because we have a negative times a positive, and that's negative 50, equals 126. Alright? Now, here again is where some of the rules get kind of fluid or lucid. It doesn't matter the order in some of these. The reason I say that is because the next step says to combine like terms, which you could definitely do. But you could also skip to the third step, which is move the constant, and then go back to the second step. As long as you are doing everything, doing what you do to one side to the other side, you're fine. With combining like terms, that can really happen at any point in time. So let me show you both ways to show you that they work. I'm going to combine my like terms first. Come on. And here on this side, I see that I have two terms with m's. So if I combine those like terms, 4m minus 15m, I'm left with negative 11m, I don't know why I spaced that, minus 50 equals 126. Then I can go on to the third step, add 50, I'm adding because that's the inverse operation of subtraction. So negative 11m equals 176. And then divide both sides by negative 11. And we should get m equals negative 16. Right? Before I go ahead and show you the other method on how to do this, I just want to double check that that does work, because remember, we should always be double checking. Right? So I'm going to, instead of typing in negative 16 every time I have an m, I'm going to go ahead and store negative 16 as m. Where is that? Here. So that every time I press m, it will automatically do negative 16. Right? So for m, oops, I did e somehow. Oh, I pressed second, not alpha. Minus 5, then in parentheses, 3m plus 10 equals 126. And this told me that this is correct. So all of this is correct because there's a negative 16 in for m. Right? The other way on how to do this is if you add 50 first, so let me duplicate this. And then I'm adding 50 to both sides first. Well, then I end up with, not this per se, I have to change it a little bit. Because at this point I haven't done I haven't combined my like terms. But once you combine those like terms and you get negative 11m, you'll end up right back here. So combining like terms is not a necessary first step. Just wanted you to keep that in mind. Right? For number 10, you have to get k by itself. Right now, k is being subtracted by 12, or 12 is being subtracted by k. No, I think I had it right the first time. And then all of that is being divided by 9. You can't do anything to the negative 12 until you get rid of that 9, because the 9 is under both, or this entire thing is being divided by 9. So to get rid of that 9, you have to take the inverse operation, which is multiplication. So if I multiply this entire thing by 9 and multiply this by 9, these two 9s cancel, become 1. That was supposed to be a k. And then this becomes a simpler equation. I'm not going to solve the rest of that because I feel that you are very capable to find that answer. And the answers are posted. Right? So in a minute I'm going to show you a couple other ways you could solve these problems. And this other method I'm going to show you is completely, if you'd like this method, use it. Alright, in this, it's breaking these steps down on how to solve these equations. Now, these equations are not complex. They're really two-step at most. Still multi-step because it's more than one. It's just not combining like terms and distributing and things of that nature. So this just kind of helps you refresh your memory as to what steps you need to do. And of course, if you feel like the other ways helped you better, use those. You don't have to use this. It's just another way to help you. So I'm going to go over this first example in this first row. So it gives you the equation. That's your example equation. And then they want you to write out these steps. Well, in these steps, or in this column, step 1 is always pick a number. That pick a number is like your variable. You could replace that and say pick a variable, anything to that nature. So pick a number. So that's your x. I'm going to try and color code this. Then it's saying whatever variable you chose, you are now going to multiply that by 7. So different color. And then, after you add that, after you multiply that by 7, you are going to add 5. And then the last line of these steps is always the result is whatever it equals. So the result is 26. And that's that last step. Then in this answer column, it kind of works backwards. It always starts off with the last thing you said in the steps column. The result is 26. And then you're doing the opposite of what you said here in reverse order. So the result is 26. That's the first step in the answer column. And then if you go back to number 3 in the steps column, you're doing the opposite for the answer column. So instead of adding 5, you are now subtracting 5. Same thing for the next step. Instead of multiplying by 7, you are now doing the opposite and dividing by 7. And once you've done all of these in between steps, the last, I'm going to change the color of this. The last step in the answer box is always, what is the number? This is when it's asking, what does the variable equal? What is the solution? Now, in this check column, it's doing two different things. The first thing it's doing is taking whatever you put in the answer box and working that out. So, again, I'm going to color code this. So the result is 26. Subtract 5. Here, this is just saying the answer when you subtract 5. So I'm not going to circle this or anything like that because that's not our final answer. After you subtract 5, divide by 7. And when you divide by 7, your number or your answer should be whatever is left, which happens to be this 3. So that is the answer, or the solution. So these first two lines is the answer put into the checkbox. This last is actually double checking to see, does this work? 7 times your solution, add 5, and the result is 26. So it's kind of putting it back in or evaluating, but it's also going through the steps as well. So the equation and the steps are both kind of combined with this number sense. I'm going to write that down. Let me do this first. I can't spell today. And then this last part, if I can get this rolling. Is, whoa, what just happened? Wow. The equation double checked using the steps. No. I did not want that to happen. Okay, so that's just to kind of give you what's happening. I have to change the size of this. Sorry. Okay. Now, we're going to do this example together. And I might do one more or do all of them. We'll see. So the first step in the steps column is always pick a number. That's not going to change. That's our variable. I'm going to say that that's x. The next step, we have to see what is being done to x from the example. Directly, or right next to the x, is a 2. Remember, when you have two things next to one another, they're multiplying. So I can say that our next step is to multiply by 2. Next step is to see what else is happening to this variable term. Well, it's being added by 4, so I can say add 4. And that's everything that's happening on the left side. So the last step would then be the result is 8. Right? Now, we're going to use these to help us do our answers. Remember that the first step of the answer column is always the last step from the steps column. So we're going to start off with the result is 8. Now we're kind of working backwards. So instead of going 1, 2, 3, 4, we're starting at 4 and we're going up to 3, but we have to do the opposite. So we are now going to subtract 4. And we're still going up, so we're going to go up to number 2, multiply by 2, but we're doing the opposite, or the inverse. So we are now going to divide by 2. And then because those were the only 2 steps, our last thing to say here is, what is the number? And we're looking for what is x. Right? Now in the check column, we're going to do the answers. Starting off with the result is 8. And we are going to subtract 4. Well, that would give us 4. Then we are going to take what we just found and divide that by 2. And that will give us 2. So this is saying 2 should be what x equals, or what our number is. Now to make sure this works, we're going to go back and put it into our original equation. 2 times the 2 we found or this 2 from up here plus, let me do it like this. You can either put it in all together or you can separate it how it was in the first example. So we know this is 4. And then this is being added to 4. And that result is 8. So that works out. So like I said earlier, this is just a way to check this. Now, I'm going to leave this one blank. Of course, the answers are already posted. And I want you to try this one to see if you can figure that one out. So notice that here, instead of giving you an equation, they gave you the steps. See if you can find the equation from these steps, find the answer, or what you would put in the answer column, and then do the check part for this one. I'm going to start with this one, or this last example. And really the order here doesn't really matter. I could, from this, go backwards and do this one, and then find my equation. I could start with part of my check, go back and do my steps, find my equation, and then do the last part of the check. So that's a little bit more work, but it doesn't matter. I'm going to go ahead and work to my left and then come back and do the check last. Right. So even though I don't know what my equation is, I know the first step is still pick a number. Now this is where it gets a little tricky, because now I'm using my answers to work backwards. I know that the very last thing in my steps is going to be the result is 24. This add 4, I have to do the opposite, but that would be the second to last step. This multiplied by 10 would be the step right under pick a number, but I have to do the opposite. So you kind of have to think about it like this, like that. You're going in the opposite direction from step to answer. So this is divide by 10. And then the next step would be subtract 4. Oops, I forgot my number. And then our last and final step would be the result is 24. And before I go on to do the equation, I can make sure that this matches up. So first step, pick a number. Actually, I'm going to start with the last step to see if these match. Last step is the result is 24. Well, that matches with this first step. These two should be opposites. Add 4, subtract 4, yes. These two should be opposites. Multiply by 10, divide by 10, yes. And then the first step is pick a number. So that looks good. Now in my equation, I'm going to say my number or my variable is x, but I'm not going to put it down just yet. And it wants me to divide by 10. So if I have some variable and I'm dividing it by 10, it would kind of look like a fraction. But then it wants me to subtract 4 and then have the result be 24. So it looks a little different than the equations we had been working with. But let's see if everything still works out. So I'm going to go ahead and do the answer part of the check. So start off with the result is 24. We're going to add 4. And that gives us 28. From then, we are going to now multiply by 10. and that gives us 280. So it's saying 280 is our variable or our solution. Now let's double check that with our original equation. Let's see if I can move this down. There we go. So this is going to disappear when I click in the box, but it's x over 10 minus 4 equals 24. I don't know if I can copy that so we can see it. Let's try. Oh, yep, that worked. Alright, so then we're going to take our number that we just found, 280, and divide by 10. That should give us 28. From there, we are going to subtract 4, and that should give us 24, which is the resulting number that we needed. That was supposed to be a check. So this is just another way to kind of go about looking at this. Of course, these are for the more simpler equations, but you could do something similar for the more advanced or more complex equations. The last part of this video is going to be doing some word problems together. I know you're probably like, word problems. It's okay. We will work through them together. Alright, so as with any word problem that we ever face, one, we need to read it. So number 1, the length of a rectangle is 3 inches more than the width. The perimeter is 30 inches. Find the dimensions. 2, the second thing we need to do is highlight, underline, circle anything that's important. So I can say the length of a rectangle is 3 inches more than the width. That seems pretty important. Something else is that the perimeter is 30 inches and it's asking us to find the dimensions. That means the length and the width. So with this, it kind of helps me if I draw a picture first. So I'm going to do that. Right? And I'm going to write out what I've been given. The length of a rectangle is 3 inches more than the width. Well, if this is length and this is width, I haven't been given any information about my width, but I have been given that the length, there's a cursive L, is 3 inches more than the width. How would we write that or translate that? If you were thinking 3 plus W or W plus 3, that is correct. Right? Now we need to know a little bit about perimeter. So if you recall, perimeter is adding up all the sides. So I could say that there's 2 side lengths and 2 widths, 2 side widths. I don't know if that made sense. So when you add up all the sides, that was supposed to be an L. It kind of looks like that. A way to simplify that and how you'll see perimeter later is since there's 2 of these, I could combine like terms, because we know how to do that, and say this is really 2L plus 2W. Same thing, it's just a little bit more simplified here. Now, let's put in what we know, or substitute in things we know. We know the perimeter is 30 inches. We don't know anything about the width, but we do know that the length is 3 plus W. Now, you may have not done this before, but it's going to be very similar. think back to when we were evaluating and what that meant. We took whatever, let's say evaluate x or 3 for x or something like that. We took that number and every time we saw x, we put that into the equation. Well, now we have an equation for L, but we're still going to use that to evaluate. So I'm going to use this and I'm going to put it in parentheses and say that this equals L. So anytime I see an L, I'm going to put in parentheses 3 plus W. Oops, that was supposed to be a W. Now we can solve this like we've been solving our problems, our other problems. We can distribute first. Let's see if I should be able to type this now. So 30 equals, we are multiplying the 2 to the 3 and the W, so 6 plus 2W plus 2W, because there was already a 2W out here, so there should be 2, one from the distribution, and then one from the original. Now, if you're following that order of distribute, combine like terms, move a constant, and then get the variable by itself, you could go ahead and combine your like terms. But remember, like I said earlier, you don't have to do that first. You could get rid of the constant first. The order there does not matter. I'm going to go ahead and combine my like terms, but if you choose to move the 6 first, that's fine as well. So I see that I have 2 sets of 2W's. So when I combine those or add them together, because they're both positive, I get 30 equals 6 plus 4W. Then I can go ahead and move my 6 over by doing what operation do you think? This is a positive 6. Positive relates to addition. So there's an invisible plus sign in front of this 6. We just don't write it. So that means I have to do the opposite and make it negative by subtracting. Alright, so 30 minus 6 is 24, and we're left with 4W on this side. And then we can divide both sides by 4. And we can say that 6 equals W. Now, that's just one of the lengths. It said find the dimension, so we have to find both the length and the width. Luckily for us, it told us that the length is 3 inches more than the width, or 3 plus W equals L. So if I know the width is 6, length has to be 9. And I forgot my labels, so this should be 9 inches, 6 inches. And then the very last thing we need to do is just double check to make sure that everything looks okay. So I'm going to go back and I'm going to use this perimeter, or P equals 2L plus 2W. I'm going to do that up here because I ran out of space. We know P equals 30. And we're saying 2 times L, which we found to be 9, plus 2 times W, which we found to be 6. And we're going to see, is this true or is this not? Now you could put this in your calculator. I'm just going to go ahead and do this by hand. 2 times 9 is 18. 2 times 6, I'm sorry. 2 times 6 is 12. 18 plus 12 is 30. So that works out. So our dimensions are 6 and 9. Alright, and this next problem, let's go ahead and read this. To mail a first-class letter, the U.S. Postal Service charges a flat rate of 53 cents and 18 cents for each ounce. It costs $2.69 to mail your letter. How many ounces does your letter weigh? So again, first thing, highlight, circle, underline anything that's important. Of course, all of the numbers aren't important, so 53, 18, 269. But there are other things that go along with this that are also important. For each ounce, so I'm actually going to change this color. It's 18 cents for each ounce, so that's really important. And then what it's asking us, how many ounces does your letter weigh? Right? So in this first example, we didn't really have to define our variables because they kind of told us length, width, and this is the actual formula to find perimeter. In this case, however, we don't have a set variable. You can use X, you can use Y, you can really use any letter you want. I would, however, say maybe stay away from using the variable O, because you might confuse it for a 0 in your problem and then things get a little messy. So use anything else besides O. If you're thinking ounces, the abbreviation is OZ and you want to use Z, that's fine. Just make sure your Z's don't look like 2's, because I often have that issue. I'm just going to say that this is X. So I'm going to say X is the number of ounces or the weight. So remember that your variable should always be something you don't know. And we don't know how many ounces the letter weighs. Now that we have our variable, we can go ahead and translate this word problem into some equation. We have to think about different things here. So it costs $2.69 to mail your letter. That's total, altogether. It doesn't say those words, but you kind of have to take that from context. It costs $2.69. It wouldn't be, it would say something if it was like just for a certain thing. But when it doesn't say like altogether or total, it still means total or altogether. I know that's confusing. So I can say 269 equals. Now, total or altogether is usually what operation? If you said addition, you were correct. So we're going to be adding these two things together. So I'm going to start off with 0.53 plus 0.18, or 18 cents and 53 cents. Now, somewhere in here, we need our variable. Number of ounces for weight. Where do you think this variable goes? Remember in the problem I highlighted for each ounce? We don't know how many ounces the letter weighs, so that X is going to go with 18. Alright, now we have an equation. Now we can solve this equation for X. What would be the first step? Oops. I'm still in highlighter. You should subtract your 53 cents from both sides. to get $2.16, and then divide everything by 18 cents. Right, so once you do that, you should get x equals 12 ounces. Now let's double check this, make sure it works out correctly. I'm going to put this into our calculator this time. 269 equals 53 cents plus 18 cents times 12. And we got a 1. This is correct. Right, so our final answer was 12 ounces. Okay. This next one looks complex, but it's very similar to number 2. There's just more steps to this. Alright, and this next one, I'm going to read this part and then we're going to walk through each. The total cost to rent and drive a car for 1 day is listed below for the 2 car rental agencies. Blue Car Rental charges $27.60 to rent a car plus 18 cents per mile driven. Red Car Rental charges $40.40 to rent a car plus 14 cents per mile driven. Alright, so before we continue, let's highlight or underline or circle. $27.60, that's just to rent the car for blue. And then we have 18 cents per mile driven. That means I was getting ahead of myself. We'll talk about that here in a second. And then for the red, it's $40.40, sorry, to rent the car, and then 14 cents per mile driven. Now, we are going to use the same variable for both of these, but what we don't know so far, not even reading and everything else, is how many miles were driven. So I'm going to say that that's M. And if you want to say D or P or anything else, that's fine. So this is number of miles driven. Right? Now, A asks us to write an equation to represent the total cost to rent and drive a car for 1 day. We don't know the total cost yet. So I'm going to say the total cost equals, now for blue, we know they charge $27.60 to rent the car, plus, so we can already say that's an addition, 18 cents per mile driven. We don't know how many miles were driven, so that's going to be our variable M. And then the red car rental is going to be very similar. Except now theirs is $40.40, and it's 14 cents for every dollar. I don't know why I said that, for every mile driven. Okay. Now, let's think about this really fast. What if they didn't drive any miles? Could you find the total cost? The answer to that should be yes, because if they didn't drive any miles, that's 0. If you put 0 in for m, remember your multiplicative property of 0, anything times 0 is 0. So if you didn't drive any miles, you would still get charged this $27.60 and this $40.40. That's what I started to say earlier, but I got ahead of myself. Now we are actually looking at the total cost. So this is like breaking this step by step by step by step. We're looking at the total cost at each agency to rent the car for 1 day. So they're just driving it 1 day, but they're driving it 280 miles. So now in this scenario, we know how many miles were driven and we have to find the total cost. So here, instead of just m, now we can say this is 280. Same thing for the red car. And then we can go ahead and figure out what that equals. So I'm going to go ahead and pull up my calculator. 27.60 plus 0.18 times 280. 78. This is in dollars right now because right now we're looking for the total cost. And we can do the same thing for the red car. Maybe if my calculator comes back up. There we go. So $40.40 plus 14 cents times 280. $79.60. Ooh, excuse me. Now in D is asking us which company is the better deal by finding the savings. So the savings here is which one costs the least amount. You want to save as much money as you can. The answer, which one is less, is the blue car rental agency. And the amount of savings, so to find that savings, we would subtract these two numbers, $78 from $79.60, and get $1.60, sorry. So I can say it's cheaper by $1.60. Now, if that $1.60 means nothing to you, go ahead with the red car rental. Doesn't matter. Now, I put myself in this problem, and now I'm saying I'm going to rent this car and drive it 400 miles. Off topic, I have driven 400 miles before. My family lives in Ohio, so that's about a 200, almost 300 something mile trip. I used to live in North Carolina and drive to Ohio, and that was like even longer of a trip, but I digress. So now we want to do the same thing, drive both cars, or see which would be cheaper for both of these cars. Right, so we're still looking for total costs, but now the number is 400. Ooh, not 4,000. Never driven 4,000 miles all at once. Take a second, try and do that on your own. Pause the video. Right? Now, something weird happened, because before we drove the car 280 miles and the blue car rental agency was cheaper. But now that we have driven it 400 miles, the blue car rental agency is actually more expensive, which is weird. So now the lower cost is the red car. I'm just going to do this to say that this one is now the lower cost. Later in these modules, we'll talk about why, not really why it's lower, but where you can find it, that they would be the same price or same cost. We're just not going to do that right now. You could definitely look into that on your own, or come have a conversation with me about it. It's just, we will come back to this, just not today. Alright, now for F and G, the last two questions. Now it's giving us the cost, and we need to know how many miles we're driven. So it's kind of doing the backwards version of what we've been doing all along. So I'm going to take this equation and kind of get rid of some stuff. Because now we don't know how many miles, but we do know it costs $7.20. And then for the red car, we don't know how many miles, but we do know it costs $83.40. So now this looks like the examples we usually are solving to solve for the variable. So let's do that. I'm going to kind of do these both at the same time, because if you're still watching this, thank you, because I know this was a very long video. Sorry about that. If you got it early on and then maybe skipped through, thanks for sticking with it. I'm just going to try and do this as quickly as I can. Oops, I started doing the wrong thing. Should be subtracting 40/40, not 83/40. Alright, so here we have left $43.60 equals 0.18 or 18 cents times M. And then here we have $43. I knew that. $43 equals 14 cents times M. And then we just have to divide both sides. So divide by 18. That was supposed to be an 8. Divide by 14. Here we have 2.42 or $2.40 equals M. And here we have 307. Oh, I didn't put the decimal. I was like, those should be similar. Hold on. There we go. It should be 242.22. That makes more sense. And then 307.14. Now, when you are dealing with word problems, you have to think about, can you have decimals in these word problems? When you think about miles, can you have 0.14 or 0.22 of a mile? Yes. I know you may not look at your parents when they drive, but every mile it counts up. So there are decimals and fractions in miles. You actually label this miles. Wow, I cannot spell. Alright, so that was a little bit longer of a process than I wanted it to be, but now we've gone through some word problems, and you should be able to try the last 3 word problems. Again, the answers are posted, so refer back to that.